Welcome to this feature video on the UDOMORE Depth Ocean plugin to Petrel. In this video, we showcase two important features of the plugin. First, the stochastic multi-layer approach to time-to-depth conversion. Second, the stochastic approach to uncertainty characterization on velocity and depth models. Both features combined strongly impact depth and associated volumetric estimations. Let's set the scene. The dataset we are using includes 3 time interpretation horizons, seismic interval velocities, and well tops. Based on this dataset, we aim to build a structural depth model and compute volumetrics on target layer 3. We will benchmark 2 scenarios using exactly the same input data. One scenario using UDOMORE depth, the other using a mainstream deterministic approach. So let's get started. Using Bayesian co-kriging, UDOMORE depth integrates all sources of depth conversion uncertainties simultaneously throughout all layers. We input time interpretations with uncertainty, well tops with uncertainty, seismic interval velocities, a rescaling factor set to 0.95 with uncertainty, and velocity residual uncertainty. The software best estimates the velocity model parameters by minimizing well depth mismatches and offers interactive graphic control. The outputs are unbiased depth estimations, quantified uncertainty on depth estimations, and optimized interval velocity maps. Using exactly the same input data and velocity model parameterization, including a 0.95 fixed rescaling factor with no uncertainty, these are the depth maps tied to the wells resulting from the mainstream deterministic approach. These are the depth estimations also tied to the wells resulting from UDOMORE depth. When visualized on a vertical cross-section, the UDOMORE depth map is 30 meters shallower between well locations than the mainstream deterministic depth map. The deterministic layer cake approach does not consider uncertainty on the velocity model parameters and only flexes the depth surface to tie large depth mismatches to the wells. This results in biased depth maps. Alternatively, the stochastic multi-layer approach best estimates the velocity model parameters inside the uncertainty range in order to minimize the well depth tying residuals. This results in unbiased depth maps. The impact of unbiased depth estimations on volumetric computations is strong. Gross rock volume figures computed using the mainstream deterministic approach are unrealistic because they neglect uncertainties on the velocity model parameters. With consistent uncertainty characterization, gross rock volume figures computed using UDOMORE depth can be trusted. The same impact is visible on structural closure probability maps. With UDOMORE depth results, you produce probability maps which are more reliable and better support E&P decision making. The stochastic multi-layer approach with UDOMORE depth has produced excellent results in E&P onshore and offshore operations. The output depth and velocity models, associated volume predictions and probability maps are recognized for accuracy, better consistency through time, and are easy to update as new data comes in. This framework is made seamlessly accessible to users thanks to the UDOMORE Depth Ocean plugin to Petrel. For additional information and a demo, contact SaySquare.